All right, we are continuing on with this chapter. We are working with solving systems. Last week we did by graphing, so we graphed two lines and we found where they intersect. We also plugged points in to see if it worked in both equations. Is this ringing a bell?
Yep.
Okay. Today we're going to learn another method for solving. It's solving systems by substitution. Tomorrow we'll review these two methods. You will be free from math for 5 whole days. There is no homework over break. When you come back, we're going to learn another method, the elimination method, and then we'll slow down, review, and quiz. Any questions on the schedule coming up? We will finish this chapter before finals, so no need to worry. All right. So this is when we would use substitution. So I would use the substitution method when the coefficient of one of the variables is a 1 or a negative 1. So to use substitution, you have to get either the x by itself or the y by itself. So it's easiest to do that when your variables have a coefficient of 1, or if they have a coefficient of negative 1, you can just divide everything by negative 1, and then you're good to go that way. All right? Here are the steps we're going to follow when we do substitution. We're going to solve one equation for a variable which has a 1 or a negative 1 as the lead coefficient. So if you have like x plus 4y, we would get the x by itself so that we can plug it in to the other equation for the x. All right? That's why it's called the substitution method, because you get a variable by itself and you substitute it in to the other equation. All right, then we solve the new equation after we substitute the value in. Then we plug the number in that we get back into one of the original equations to find the value of the other variable. It sounds really complicated. These steps make it sound like a lot more work than it actually is. You're going to get a variable by itself. You're going to plug it into the other equation. You're going to solve. You're going to plug it back in. You're going to solve again. Remember, systems of equations have an x and a y. So it's kind of like two problems in one. You have to find the one variable, then the other variable. All right, I think it'll make more sense when we actually look at an example. So here you go. Example 1. So we have y equals 2x. That's our first equation. Second equation is 2x plus 5y equals negative 12. Do you see how the first y is already isolated? That's what we meant when we said like coefficient of 1. Technically, it's a 1y, right? It's already by itself, so we're good to go. So what we're going to do is we're going to take that value, this guy right here, we're going to plug it in for this variable in the other equation, okay? So y and 2x are the same exact thing, right? So I'm going to take this y out. I'm going to put a 2x in instead. So I'm going to rewrite that second equation, but instead of a y, I'm substituting in what y equals. And now I can solve for the x. The whole point is you got to get rid of one of the variables first. You need an equation that's either all x's or all y's. All right, so 2x plus, what's 5 times 2x? 10x equals negative 12. How would I solve this? Good, so I get 12x equals negative 12. Divide by 12. Divide by 12. X equals negative 1. I am going to pause there. So my solution is always an ordered pair. So the first value of my ordered pair is negative 1. That's what I just found. Now, I am going to take this. I'm going to take this. I'm going to plug it back in to the place where y was by itself. So y equals 2 times negative 1. Well, what's 2 times negative 1?
Negative 2.
Negative 2. Wow, that was magical. All right, now, real quick, in my head, I'm going to just check to see if this makes sense. Does negative 2 equal 2 times negative 1? Yeah. It does. If I plug a negative 1 in here, I'd get negative 2 plus negative 10. Does negative 2 plus negative 10 equal negative 12? Yeah. Boom. Checks, checks. I feel confident moving on. What are your questions? All right. Here is part B. Now this one's a little trickier because we don't have a variable all by itself yet. Do you see one that will be really easy to get by itself? Which one? The top, which variable? Yeah, so I'm going to go for this guy right here. How am I going to get that by itself? Subtract 3y, right? I want to get that x by itself. Like that. Okay? So I have x equals negative 3y plus 7. Or you could do 7 minus 3y. I don't know why I chose to do it like that. I don't know. I'm just used to sneaking the variable up by the equal sign from last chapter. All right, any questions on what I did there? That was a crucial step. If you have 7 minus 3y, you are still good to go. Now, I am going to take this bad boy, and where am I going to put it? Where x is in the other equation. So now I have 2 times negative 3y plus 7. And then just continue on with that second equation. Minus 4y equals negative 6. Now what? You start doing the problem. Thank you. It's very insightful. Distribute the 2, so negative 6y plus 14 minus 4y equals negative 6.
You want to add negative 6 and negative 4y?
Yeah, get these bad boys together. So negative 10y plus 14.
Minus 14. Oh.
Mm-hmm. Now those are both negative. So I'm going to add them and keep the negative sign. And when I divide by negative 10, what do I get?
2.
Good. A negative divided by a negative is a positive. Okay, so over here. I didn't leave enough space. All right, so I have blank, comma, 2. That's my x, or my y value. I'm looking for my x. Yeah, I'm going to pause because I feel like we got a little fast there for a second. Now, you can plug it back into the original. In the next method I teach you, I always go original. Just, I don't know, it just makes me feel good. Here, the easier one is actually this guy. So I'm going to take this, and if I put it right here, do you see how x is already solved? Like it's already isolated? So here we just have to simplify an expression. We don't have to solve an equation. If you plug it into the original, you should end up with the same answer. All right, so x equals negative 6 plus 7, which is what? 1. Which is 1. So now I have a 1, comma, 2. I'm going to box it in, but I'm still going to check it. All right, so when I plug it in here, I'd have 1 plus 6. Does 1 plus 6 equal 7?
Yes.
All right. Down here, I'd have 2 minus 8. Does 2 minus 8 equal negative 6? Yeah, so this checks out. Checking it is real quick. You don't have to even write it out, but I would definitely like pause and check it each time. What are your questions? All right, here is number 1, part C. All right, what, as you're writing it, think of which one you want to get by itself. The first what? First equation, the first what? Yeah. All right. So add 4p. Okay. So right now I have x equals 4p plus 8. Right. All I did was add 4p. Add 4p. And then I'm going to plug the x, plug this value in for the x in the second equation. So I have 2 times 4p plus 8. And then just keep on going. So minus 4p equals 6. Then what? All right, 2 times 4p is 8p plus 16 minus 4p equals 6. 8 minus 4p is 4p plus 16 equals 6. Subtract the 16. Oh no, a fraction. Should I quit?
Yes.
No.
I don't like fractions. I like whole numbers.
All right, so over here I'll have p equals negative 10 over 4, which simplifies to what? Negative 5 over 2. Now, this is where it gets kind of tricky. Normally we put the x in the front, right? When it's not x and y, though, I want you to go with alphabetical order. So should the p be in the front or the back? The front. Yeah, it's actually going to be p and then x. I don't like that. This one honestly makes me uncomfortable, but we're going to stick with alphabetical order always, all right? It just feels weird to not put the x in the front, but the laws of the way to do it tell us to do it that way. I'm sorry. I feel like I'm stuttering a little. I don't like it. I don't like to put the x in the back, but I'm going to do it, okay? Now, yes, I'm going to plug in negative 5/2 for p. You can go back to the original if you want. Here, x is already isolated. So this is going to simplify, and I don't even have to do any inverse operations. I can just do the math over there. Now, the 2 and the 4
Turn into 1 and 2.
yeah, become a 1 and a 2. So that's going to be negative 10 plus 8, which is what? Negative 2. Ugh, I don't like putting the x in the back, but I'm going to do it. All right. I am very uncomfortable by this problem. All right, so when we plug these back in, we would have negative 2 here plus the 2 and the 4 would become a 2, and then 2 times 5 would be a 10. So negative 2 plus 10, does that give me 8? Yeah, when I plug it in here, I have negative 4 plus 10 again. Negative 4 plus 10 is positive 6. So I'm actually good. You might want your calculator to check this one. Just fractions in your head is kind of tricky, but it does check out. Questions? All right. Are we good? All right. How should I start? Well, I'll give you a second to write it down. Then we can start working through it.
Subtract 5b. Add 5b.
Come on now. Calm down. Get the program. Sorry.
All right. What do I do? Shh.
Add 5b.
Add 5b in the first equation. I'm going to get that a by itself. All right. So again, if you want to sneak the 5b by the equal sign, you can. That's just kind of what I'm used to doing. Here, it has the 10 in the front. Either way, it's fine. Addition is commutative, so order does not matter. All right, what am I going to do with that?
Put it into the second equation with an a.
Yeah, I'm going to put it into the other equation where the a is. So I have 2, and then in parentheses, 10 plus 5b or 5b plus 10. Minus 10b equals 20. Then what? Distribute the 2. Good. After you distribute the 2, you should have 20 plus 10b. What is 10b minus 10b?
Equals 20 all real numbers.
So 20 equals 20.
20 equals 20.
Is that true?
Yeah.
It is true. When you get something that's true, think back to what this graph would look like. What would the graph look like?
Same line, one line.
It'd be the same line, one on top of the other. So you cannot say all real numbers because you have 2 variables, and not every combination of every number in the whole wide world makes this equation true. But every ordered pair that's on one of the lines would also make the other line true. So there are infinitely many solutions. However, it's not all real numbers. It has to be a certain combination of numbers. So it's all ordered pairs on the line. All right. Now, the variable n is already by itself. So I'm going to go with that one. You go ahead and go for it and let us know how it turns out, okay? So n is already isolated. Go with the n. So I'm going to plug 2/3 m in for the n in the second equation. Why would I not do that? All right, so this is what it looks like. Now, in the perfect world, the 7 and the 3 would simplify, but, you know, nothing's perfect. All right, so multiply the 7 and the 2. You get 14. Below the 7, we know there's a 1. 1 times 3 is 3. Now, I need to get common denominators. What's my common denominator going to be? 3. All right. So I'm going to make that a 6/3, right? So 6/3 m plus 14/3 m equals 4. So this is 20/3 m equals 4. And then what? Multiply by the reciprocal. Or yes, you could get rid of the fractions right away. We've learned that method. Or just type it into the calculator and be done with it. But this is one of the methods to solve. So I have m equals, that would be what? Yeah, you could, what?
Why didn't you subtract?
They're on the same side of the equal sign. So I'm just combining like terms. So yeah, you can simplify up there. I feel like I'm doing a little too much. I'm just going to show it, okay? They're both divisible by 4, so you end up with 3 over 5. If you simplify the 4 and the 20, like cross simplify, you get the same thing. All right. What are your questions? A lot just happened. You don't know what I did. All right, everybody be quiet. Shh. Some people are not seeing what's going on. So from here, I have 2 m's on the same side of the equal sign. I need to combine them. If I have a calculator, I can just go for it. 2 plus 14, ABC button 3, equal sign, and then, right, just go from there, okay? But I don't have a calculator. I'm just going to do it, okay? So common denominators, I need to multiply top and bottom by 3 here. I get 6/3. Add those, I get 20/3. Multiply both sides by 3 over 20 to get rid of this fraction. Other methods would be, at this point, stop and distribute a 3 to everything and just get rid of the fractions and go from there. You'll end up with the same answer, okay? There are multiple methods to solve these equations. If you want me to double check if your method works, you can. But if you do a different method and you get this answer, I mean, it's fine. That's okay. If you're trying another method and you're not getting this answer and you want to talk about it, we can go for it. Anyone feeling stuck? No? No? All right. So we are going to plug this back in for the m up here. So n equals 2 over 3 times 3 over 5. So it's just going to be 2 over 5. All right, what comes first in the alphabet?
M.
I mean between M and N.
You know what comes into the alphabet?
Oh my gosh. M is first. Wow, that was great. All right, this one I would not struggle through checking this. I would plug it into the calculator, see if I get it, but let's just go ahead and trust each other. Any questions on this one? It's a tricky one. What?
Never mind. No,
What?
I didn't see the.
Yeah, this guy's already isolated. All the other ones we did the first equation, but yeah, this guy's good to go. So I am gonna plug 3y minus 5 in right here. Even though this x doesn't have like a coefficient in the front, remember there's a -1 we're going to have to distribute. So make sure to keep it in parentheses when you write it. You guys need to get a little chit-chatty back there. All right, distribute that negative or that -1. So we'll have 2y minus 3y plus 5 equals 7. The y's are on the same side of the equal sign, so you can go ahead and subtract them. What is 2y minus 3y? -1y. There is a hidden step here. Minus 5 minus 5. What's 7 minus 5? 2. And then we can divide everything by a -1. So what's y equal? -2. All right, when I plug in -2, hold on, I'm going to plug it into where x is already by itself. If you want to plug it in the top, go for it. You'll get the same answer if you do it right. But since the x is already by itself in that second equation, I'm going to do 3 times -2. That's -6. Minus 5 is -11. So my answer is -11, -2. When I plug it back in up here, I would get -4 plus 11 equals 7. That's true. Here I'd get negative 11 equals negative 6 minus 5, the math that I just did. That one's true too, so I'm feeling pretty good. Questions? All right, the sum of two numbers is 60. Twice the larger number is 10 less than 8 times the smaller number. Find the numbers. Oh my goodness. All right. Let's start just reading through it again. The sum of two numbers is 60. So I'm going to call X the first number, Y the second number. All right, what do I know about X and Y? When you add X and Y, you will get 60. Twice the larger number. All right, so I'm going to go back and make a note. I'm going to call X the larger one. Okay. So twice the larger number. How would I write that? 2x is 10 less than, so that means a minus 10 on the end, 8 times the smaller, 8y. Any questions how I did this? All right, which variable do you want to get by itself in which equation? The x in the first one, I can go for that. So I'm going to subtract y. So I have x equals 60 minus y. I'm going to take that. I'm going to plug it in right here. So 2 times 60 minus y equals 8y minus 10. So 120 minus 2y equals 8y minus 10. All right, I'm going to do 2 steps at once. I don't recommend it, but I am out of space. I'm going to add 10 to both sides while I also add 2y to both sides. Everybody down? All right, so right over here, I'll have 130 equals 10y. So what's y equal? Whoa. 13. I'm sorry. I got a little carried away there. All right. Now what? I do what now? Plug it right back into here. So x equals 60 minus 13, which is what?
70, no, my bad, 50, no, 22, no, 47, 47, got it.
Very good.
Yeah.
Now, if you want to list this one as an ordered pair, that's fine. Since it didn't really specify, that these are X's and Y's, I'd probably just write them as just list them as 2 numbers, Okay, now I am going to double check that this actually works. I'm going to read through the problem one more time. The sum of 2 numbers is 60. Do those 2 numbers add to 60? Okay, twice the larger. What is twice 47? 2 times 47 is what? 94. Okay. is 10 less than 8 times the smaller. So I'm going to do 8 times 13. And then I'm going to subtract 10. I got 94. So does this check out? It does. All right. So even when they're word problems, you can still plug them back into check. Questions? So Lisa has $8.60 in dimes and quarters. If she has 12 more quarters than dimes, how many dimes does she have? Okay. So I'm going to have two variables, right? I'm going to let D stand for what? Number of dimes. I'm going to let Q stand for number of quarters. All right. The first bit of information that I have is the value. Well, each dime is worth what? So 10 cents times the number of dimes plus 25 cents times the number of quarters equals what? 860. Okay, now we can go. So if she has 12 more quarters than dimes. So which one has more, quarters or dimes? So quarters equals dimes what? Plus 12. Good. That's always kind of hard to figure out. A lot of people will put 12 plus Q. I always ask myself, well, which one's bigger? If you have more quarters, then it would be the number of dimes plus 12. Or you could write it as the number of dimes is quarters minus 12. It just kind of depends which variable you want by itself. What are your questions? These are tricky. We'll practice these a lot. Now, I hate decimals. So before I even start solving, I'm going to get rid of them. I do not have time for these. I'm multiply by 100.
No.
Yup, I did. There you go. Get rid of them. If you multiply by 10, you'll still have you'll still have decimals with your Q. All right. Now, what's going where? Yeah, so I'm going to put D plus 12 in for the Q right here. So 10D plus 25 times D plus 12 equals 860. What is 25 times 12?
25 times 12.
300, good. All right. What next? Combine like terms, good. Are you guys okay if I combine like terms and subtract 300 at the same time?
Yeah. Do whatever rocks your boat.
I'm just out of space and I don't want to start erasing. All right, so this is going to be 35D equals 560. So I need to do 560 divided by 35. I'll write it over here. D equals 16. Boom.
Is that all we have to do for this one?
No. Wait. I spoke too quickly.
Yeah.
What is the question asking me?
How many more quarters than dimes?
No, it's how many dimes.
How many dimes does she have? So do I need to finish this problem?
Yeah, no.
That's why I asked.
I'm sorry, I gave you a smart aleck answer without even double checking. You were right. 16 times is correct. Now, if this was a problem, let's say on my SAT, and I knew I had some time left, I'd be plugging this back in. I'd find the number of quarters. I'd multiply that by 25 cents. I'd multiply 16 by 10 cents. I'd add them together. I'd see if I got 860. But for today, I think we're good on the work we've done. Any questions? Okay, I want to really quickly set the word problem up. All right, since we're low on time, we're just going to set it up, and we're going to trust that it works out, okay? The length of a rectangle garden is 4 times the width. The perimeter is 75 meters. Now, the reason I want to look at this one is because a lot of you are forgetting the formula for perimeter. It is a constant struggle. How do I find the perimeter? 2 length plus 2 width equals 75. Good. Our other equation would come from that first sentence. The length of a rectangle is 4 times the width. Okay? And then from here, you'd plug the 4W in for the L in the first equation. I think we've practiced that enough. I will do it, but just give me a second. I'm going to give people's homework out because some people leave a little early. All right, so here comes the homework, and we'll finish it up in a second if you're interested. All right, so this guy goes in right here. So 2 times 4W plus 2W equals 75. That is 8W plus 2W equals 75. 10W equals 75. When you divide by 10, we end up with a decimal. W equals 7.5. Now, see how L is already by itself?
Yeah.
So just plug it in. 4 times 7.5. Well, I know that 2 times 7.5 is 15, and that's going to happen twice, so it is 30. All right, so what are the dimensions of the rectangle? So the answer would be it's a 30 meter by 7.5 meter rectangle. I would stop really quickly and say, does 30 plus 30 plus 7.5 plus 7.5 equal 75? Yeah. And does 1 times 4 equal, one of the dimensions times another dimension equal the other one? Or 4 times 7.5 equal 30. Sorry, getting tongue-tied. Yes, this does check out. Long story short, it does. I am going to let you summarize your notes. Make sure you get it done. Solving by substitution. Very good. And you have about 30 seconds left.